And this is where this stuff becomes tricky. Okay. Now, notice that in this function that we've been given, we're given a radical. What do we assume is the sign of that radical? It's positive. It's not the plus and the minus. It's only the plus. Right? And I could graph that, and we'll explain it a little more later, but this would have a graph that looks like that. You could put it in your calculator and see what it looks like. That's what the graph looks like. When it comes to domain and range, right, the domain means the x values. On this graph starts at the point x equals -1, and then it goes infinitely to the right. So you would say that the domain is x is greater than or equal to -1. What does it look like the range is? Its values start here, and they only go up. So y is, notice how I did the domain. So how would I do the range? Y is greater than or equal to 0, right? Y is 0 is on the x-axis. So you would say the range is y is greater than or equal to 0. So we keep that in our back pocket, and now we're going to find the inverse. Okay, let's just follow our steps now. The first step is replace the f of x. Okay, and the next step is switch the x and the y. Okay. The next step is solve for y. Okay, how do you solve for y? It's inside a radical. Okay, it's kind of like we just did. We solved radical equations. First you isolate the radical, and then you undo the radical. So how do you undo a square root? You square both sides. Right, so this is squared, squared. Right, and so the square of a square root just gives you what's inside, equals x squared. Okay, not quite done. Okay, subtract 1. Y equals x squared minus 1. Okay, which means f to the -1 of x equals x squared minus 1. Okay, well, what's that graph going to look like? It's a parabola. Does it open up or down? Try again. What's the y-intercept? -1, right? It should look like a parabola like in here. So here's the y-intercept, looks something like that and something like that. Okay, but is that going to be that one of them is just like the mirror image of the other across the line y equals x? I mean, not at all. I mean, this here is a full parabola, but this is just like half of a parabola. That's where this stuff comes into play, right? Remember what we saw at the beginning. When you find a function and its inverse, they swap domains and ranges. So if this thing had a domain of x is greater than or equal to -1, this one has a domain of, this one has a range of y is greater than or equal to -1. Right? This thing had a range of y is greater than or equal to 0. So this one has a domain of x is greater than or equal to 0. Okay, well, see, in our parabola here, this left half of the parabola, x is less than 0. So it's not in the domain. See, our domain would only start at x equals 0 and then go to the right. So this piece right here is actually not part of the inverse. So we would have to go in here and take that out. Just take out that piece. Now, do those two look like they might be mirror images about a line like that? Yeah, those two do. But we would not have told that if we hadn't taken into account domains and ranges. That's why you have to take into account domains and ranges. And I know this doesn't go down easy. Believe me, in functions and pre-cal and cal, we struggle with these things. When it goes off, when somebody finally learns it, it's like, oh, you know, they get it, and after that, it's not an issue anymore. But sometimes it takes time. And I would not expect on day one, the first time you've ever looked at it, that you're walking out of here like, got it, no problem here, ever again. I wish that would be the case, but